Lesson 6 of Chapter 4 is on inverse trig functions. So here's a picture of a sine wave, and before we can get into inverse trig functions, we need to talk about functions being one-to-one. And a sine function is not a one-to-one function because it passes the vertical line test but fails the horizontal line test, and that red line on the sine wave shows that it fails the horizontal line test. So what we do with the sine wave is we restrict the domain of the sine wave to just be from negative half pi to positive half pi so that it does pass the horizontal line test, and it's a one-to-one function. That allows us to use the inverse of sine. If you took some of these coordinate points, such as negative half pi, negative 1, it would become negative 1, negative half pi right here. If you take this coordinate point, which is half pi comma 1, it becomes 1 comma half pi over here. And of course, if you take the coordinate point 0, 0 and switch that, you get 0, 0. So the picture on the right represents the graph of a sine inverse. And so the restricted domain for a sine inverse is negative half pi to positive half pi, which means that every time we use sine inverse, we're going to be looking in the fourth quadrant or the first quadrant, because the restricted domain is from negative 90 to positive 90 degrees, or in radians, negative half pi to positive half pi. So some examples. If we have sine inverse of 1/2, there's two places on the unit circle where sine equals 1/2. They are 30 degrees and 150 degrees. But 150 degrees is not within the restricted domain of negative 90 to positive 90, so that's why our answer is 30 degrees. Arc sine, you can see right here, just means the same thing as sine inverse. So if we have arc sine of negative square root of 2 over 2, that would give us 225 degrees, or 315 degrees. Neither of these is the correct answer because neither of those is between negative 90 and positive 90. So instead, we come up with an angle that's coterminal with 315, which is negative 45. Part C says sine inverse of 3, and the answer to this is no solution. Reason being is because a sine wave, if you think about it graphically, looks something like this. And if I put a horizontal line at 3, that red line will never touch the blue line. So anytime you do sine inverse, it always has to be in between 1 and negative 1. Otherwise, there's no solution. And 3 is obviously bigger than 1. Next example, arc sine of square root of 3 over 2. There's two places on the unit circle where the sine equals square root of 3 over 2, and that would be pi over 3 and 2 pi over 3. Well, this one is not within the restricted domain, negative half pi to positive half pi. So there is our result. Sine inverse of negative 2 pi, well, negative 2 pi is like negative 6.28, so this is a no solution because negative 6.28 is smaller than negative 1, and your values have to be between negative 1 and positive 1. Part C, we have arc sine of negative 1. I think there's only one place on the unit circle where arc sine equals negative 1, and that's at 270. However, that's not within the restricted domain. So our answer then is negative 90, which is coterminal with 270. So that's sine inverse. Now if we go into cosine, cosine also is not a one-to-one function unless you restrict the domain. So on a cosine function, we restrict the domain from 0 to pi so that it does pass the horizontal line test, which means then we can use the inverse of cosine. And if you take coordinate points such as 0, 1 and switch the coordinates, you get 1, 0. If you take the coordinate point right here, which is half pi comma 0, switch that, you get 0 half pi. And if you take this coordinate point, which is pi negative 1, switch the coordinates, you get negative 1 pi right here. So the picture on the right represents a cosine inverse graph. So the restricted domain on cosine is from 0 to pi, which means we'll be working with the first quadrant or the second quadrant for a cosine inverse. So a couple of examples. If we have cosine inverse of negative square root of 2 over 2, in degree measure we would have 135 or we would have 225. Well, 225 is not within the restricted domain of 0 to 180. That's why 135 would be our result. Arc cosine means the same thing as cosine inverse, and so this one would be a no solution, because just like with sine inverse, your values have to be between -1 and +1. Since -2 is smaller than -1, there is no solution for that. Cosine inverse of 0, I believe that's at two locations. We have 90 degrees and 270 degrees. The 270 is not within the restricted domain, therefore the answer is 90 degrees. A couple additional examples. Cosine inverse of -√3/2. This would have to be at 5 pi over 6, and also at 7 pi over 6. Well, the 7 pi over 6 is not within the restricted domain of 0 to pi, so therefore 5/6 pi is our answer. Arc cosine of 2.5 would be a no solution, because 2.5 is bigger than 1. Cosine inverse of -1/2 would be at 2/3 pi and at 4/3 pi. 4/3 pi is not within the restricted domain of 0 to pi, therefore the answer is 2/3 pi. The last one, the last of the three functions to talk about is a tangent. And so a tangent function also does not pass the horizontal line test. So if we restrict the domain of a tangent to just be in between the asymptotes from -½ pi to +½ pi and just look at that part of it, then it would pass the horizontal line test. And so if you graph the inverse of tangent, you get a picture of a graph that looks like the graph on the right. And so your restricted domain for tangent inverse is from -½ pi to +½ pi. So just like with the sine quadrant, we'll be working with the first and the fourth quadrants. However, please note that on the tangent inverse, -90 and +90 are unacceptable answers because tangent is not defined at 90 and -90. This is why you're seeing open circles on both of those locations. So a few examples. We have a tangent inverse of square root of 3. Well, tangent is equal to square root of 3 at 60 degrees and also at 240 degrees. Well, 240 degrees is not within the restricted domain. Therefore, 60 degrees would be our solution. Arctangent means the same thing as tangent inverse. And so we have two locations, 0 degrees and 180 degrees. Tangent inverse has to be between -90 and +90. Therefore, the answer is 0, and 180 degrees is unacceptable. Arctangent of -√3/3 would be equal to 150 degrees and also 330 degrees. Neither of those answers is acceptable because our answer has to be between -90 and +90. So we come up with a coterminal angle, which would be -30 degrees. Tangent inverse of -1, we have 135 degrees as well as 315 degrees. Well, again, neither of these are within the restricted domain of -90 to +90. Therefore, we come up with a coterminal angle, which would be -45 degrees. So here's just kind of a summary of the three inverse trig functions. You can see sine inverses on the left, cosine inverses in the middle, and tangent inverses on the right. You can see on each of these we have a domain and a range for each of these inverse functions. The range of each of these inverse functions is the restriction of the domain of the regular function. And then there's some other specifics there on those inverse trig functions.